So today, what you're supposed to do is you're reviewing for your test for tomorrow. So I'm going to show you, we're doing chapter summary is what you're doing. So what I'm going to do is I'm going to switch it over to the one paging here. I'm going to flip these things over and I'm going to go over it. So online, you have a flow chart. And so what you see here, as far as a review, I went on the flow chart, I did it, and I corrected it, and I put it on in my ISM book. And so now I'm going to go over to chapter review. We're going to do questions number 8 first. So question, and we're doing 292. So let's go see what we got. Number 8 says an object weighs 315 newtons. Sorry, I got to start my timer. Sorry. And it says it's 315 newtons. When you tie the string connected to a balance, it immersed in the water, and it weighs 265 newtons. That's the apparent weight of the water. When the immersed in oil, it weighs 269. And find the following, the density of an object. So the first thing we're looking for is we're looking for the density of it. So to be able to find the density, we are going to use this Fg divided by Fb and then P water. So what we're going to do is we're going to put this equation in our calculator. Let's see if I can get the calculator showing. Okay, so what we're going to do is we're going to do alpha y inner because it's a fraction. So we're going to open bracket 315, close bracket, open bracket 1.00 times 10 caret 3. And we're going to close our bracket, go down, and that is 5.0 times 10 to the caret 1 over inner. And we get 6,300. So that's a good enough answer. But if we want to do it scientifically, then we just do second answer, and that's 6.3 times 10 to the third. The next one is for B. We are actually trying to find the density of the oil. So we're going to do exactly the same thing we did here, except we're going to use the density of the oil instead of the density of the water. So we're just taking and changing that equation around. Instead of that, we're using this. That gives us 9.2 times 10 to the second kilograms meters cubed. Question number 9 says, a sample of an unknown material weighs 300 newtons, and in the air and 200 newtons when submerged in alcohol. It says a solution of the density is 0.7 times 10 to the third kilogram. What is the density of the material? So we took the 300 from the 200, which gave us 100. And we are actually trying to find the density of material. So we're doing Fg divided by Fb and then P alcohol. So then we're going to do this equation here. Alpha y inner. And that's open bracket 300, close bracket 0.70 times 10 caret 3 over close bracket. Sorry. All right, and now we're going to go ahead and put down the 100 newtons. And that gives us 2.1 times 10 to the third, and that's the answer for number 9. Then the next one we're doing is question number 14. And 14 says the four tires of an automobile are inflated to an absolute pressure of 2.0 times 10 to the 5th kilopascal. That's my pressure. Each tire has an area of 0.24 meters squared. That is the area in contact with the ground to determine the weight of the automobile. So then what I'm going to do is I'm going to do 4, because there's 4 tires, times 2.015. So let's see what we can do here. So that is open bracket 4, close bracket, open bracket 2.0 times 10 caret 5 over close bracket, open bracket 0.024, close bracket and enter, and I get 1.2 times 10 to the fourth. Number 22 is telling us a 7.0 kilogram man sits. Okay? In a chair that are evenly distributed on the edge of a chair. Assume that the chair makes contact with the floor over a circular area with a radius of 1.0. That's the radius. What is the pressure exerted on the floor by the table? So if the chair is 70 gram mass of the man and 5.0 kilograms for the chair, the radius is here in gravity. So what we're going to do now is we're going to do this equation here. So for that one, we're going to do alpha y enter. We're going to do open bracket 70. And then we're going to add 5.0 because we have to add him and the chair, right? We're going to multiply that by gravity. And then we're going to go and we're going to do 4 pi. And we're going to multiply that by 0.01 squared over enter. And we get 5.9 times 10 to the 5th power. And then the last one, number 27, says, a physics book has a height of 26 centimeters and a width of 21 centimeters and a thickness of 3.5. What is the density of the physics book if it weighed 19 newtons? So what we had to do is we just had to do the math here, 19, and then we multiplied it, and we should get 1.0 times 10 to the third meters per second. For B, it is asking us to find the pressure of the physics book exerted on the desktop. The book lies flat down. So we do 19 newtons times 0.26 times 21 because that's the edges. That height and width is what of the book. That's where we get 3.5 times 10 to the second. And the last one is we're going to find the pressure of the physics book on the surface. And so we're going to take 19 newtons times 0.26, but this time we're going to do the y, which is 0.035, which is 2.1 times 10 to the third. And so that is all of the review problems, but I'm going to tell you there are some other ones that you could look at if you want to. I'm going to try to post the test for you tonight so that you can get it a little early to tell you what you need to focus on and what you don't need to focus on. And then you'll have, I think I'm just going to go ahead and have you do it on Thursday and submit it on Thursday and then leave it open for people maybe a couple days after that. A lot of times I'll leave it open till Sunday, and I might just go ahead and do that so that you can have more time. But just let you know I love you and I miss you, and I hope you have a good day.